Number 1, solve the following equation. To solve it, we need to find the value for x, so I will separate my sides and we will isolate the variable x, so we will add -2 to both sides, and it leaves us with 2x equals -26, and we will divide by 2 and get 1x equals -13. And number 2, find the slope of a line that contains points 2, -1, and 4, 9. To find the slope, we use m equals y2 minus y1 divided by x2 minus x1. We will label the x and y values here in each ordered pair. It's the first set, so we put a 1. This is the second, so we put a 2. And then we just point here and here, and we use the numbers that we're using. So y2, so we go to y2, and that's 9. So I write 9 minus, so we have a minus sign here, the value of y1, which is -1, divided by x2 is 4, minus the value of x1, 2. So 9 minus the -1 is 10. 4 minus 2 is 2. And then 10 divided by 2 is 5. So m equals 5 over 1, or simplified, it's just 5. Okay, number 3, does the following table represent a linear function, y or y not? Okay, when we're looking at tables, and they're going to ask us, is it a function, is it a linear function, is it the linear parent function? We have to know the difference between all three things. Okay, so in this problem, specifically they're asking about a linear function. Okay, so a linear function, the key word here is going to be linear. We are looking for a constant rate of change. Okay. And what that means is that we look at the differences in the y's and we make a ratio with the differences in x's. So the ratios have to be the same for all of the changes in y over the changes in x. Okay, so we're going to look at the y values first. So we're going to look at the change in y. And to go from -8 to 2, that's a change of 10. So I have to add 10 to -8 to get to 2. So that's plus 10. Then to go from 2 to 12, that's plus 10. And then to go from 12 to 22, that is plus 10. And now we're going to look at the change in our x's. So to go from a -10 to a -5, that's plus 5. To go from -5 to 0, that's also plus 5. And to go from 0 to 5, that's also plus 5. So now I'm going to make a fraction out of the changes. So the change between these two on the y was a 10. So the change in y was 10. And then we're going to put that over the change in x. So the change in x in this case was 5. So from this point to this point, the y went up by 10, the x went up by 5. We write that as a fraction. Okay, then we're going to look at the change from this point to this point. It went up 10, and the x changed by 5. So far we have a constant rate of change going up 10 over 5, up 10 over 5. Okay, so then we're going to look at the last set. So we're looking at the change between this point and this point. Went up 10 on the y, went up 5 on the x. So it is consistent. Okay. And so it does have a constant rate of change. So does the following table represent a linear function? Yes, because it has a constant rate of change. And number 4, simplify. Simplifying, we're just going to distribute and combine like terms. So before we start combining things, we need to distribute. So I will take this 5, and this really means 5 groups of negative 3x minus 2. So I'm going to take the 5, and I want to distribute it to each of the numbers inside of the parentheses. So 5 times a negative 3 is negative 15, and it has an x attached to it, so I'm going to write that down. And then we're going to take 5 times a negative 2, and that gives me negative 10, so minus 10. Then I need to take this minus 4, and I'm going to distribute this. So instead of looking at it as a minus 4, I'm saying that that's negative 4. So I'm going to take this negative 4 times each of the terms inside of this set of parentheses. Okay. So negative 4 times x is minus 4x, and negative 4 times the negative 6 is positive 24, so we put plus 24. And now we'll combine like terms. So when I combine like terms, that means they have to look the same. So I can combine all of the things that have an x with them, or I can combine the terms that don't have x's with them. But they have to look a certain way. So I'm going to take negative 15x, and I'm going to add it to a negative 4x. Right, they both have x's in the term, so I can combine them, saying I have negative 15 of these x's, and I have negative 4 of these x's. So negative 15 and negative 4 added together, right, we're combining them, gives me negative 19 x's. And then I have negative 10 plus a positive 24, and that gives me plus 14. Now I cannot combine these terms because the second term here does not have an x with it. Number 5, write the equation of a line that passes through the points 4, 5, and negative 3, negative 2. In order to write an equation, I have to have two things. I have to know the slope and the y-intercept. So m is our slope, b is our y-intercept. To find slope, we need to find out what's the change in the y over the change in the x. So to do that, we use the slope formula. M equals y2 minus y1 over x2 minus x1. So we'll label x1 y1 and x2 y2. And we'll substitute the values in. So the value of y2 in this set of ordered pairs is negative 2. It's negative 2 minus the value of y1, 5, divided by the value of x2 is negative 3, minus the value of x1 is 4. Negative 2 minus 5 is negative 7. And negative 3 minus 4 is negative 7. Negative 7 divided by negative 7 is 1. Okay. So now we know our slope, so we need to take our slope with one of the points so we can find b. So I'm going to take this out so I'll have some room to work. And we are going to use y equals mx plus b. And we found that our m was 1. Okay, so we take m and 1 point. I'm just going to use 4, 5. Okay, so the y value was 5 up here in this ordered pair. So I'm going to take that 5 and put it right here where the y is. That equals m times x. M is 1, and then our x is 4, so it's 1 times 4 plus b. 1 times 4 is 4, so 5 equals 4 plus b. And then we're going to take that 4, and we want to isolate the b, so we want to take that 4 and move it to the other side by doing the opposite. So we will minus 4 on both sides. And we're left with b equals 1. So for our equation, for this line, it's y equals 1x plus 1. And I don't need that 1 there in front of the x, because if I just write the letter x, I know that I have one of them. So it's y equals x plus 1. And number 6, if x comma negative 3 is a solution to the equation 4x minus 6y equals 50, then what is the value of x? Okay, so they're giving us the value of y in this problem, right? If this is an ordered pair, so this is x and y, and they're telling us y is negative 3. So I'm just going to take that value and I want to substitute it in right here where that y is. So the only thing I don't know in this equation is what the value of x is. So let's go ahead and substitute. We get 4x minus 6 times negative 3. So it's negative 6y because the y is negative 3. And that equals 50. Okay. Then we're going to multiply negative 6 times negative 3. That's positive 18. Now we want to solve for x, so we are going to add a negative 18 to both sides. And 4x equals 32. Divide by 4. So 1x is equal to 8. So the value of x is 8. So the ordered pair would look like that. Okay, number 7, the domain of the function f of x equals 4x minus 3 is 0, 3, 6, and 9. What is the range of the function? Okay, a couple things. It's saying the domain of this function is 0, 3, 6, 9. So domain represents x. So that means these are the values of x. And I have 4 different values. And they want to know what is the range. So what are the y values? So I would just set up a simple table, x and y, and I would fill in the values that they gave me. They gave me the domain, so it's 0, 3, 6, and 9. And we just have to find the y values. Now there's a couple things that we could do. One, we could use our calculator, and where it says f of x right here, that really just means y equals. So we could do that, so y equals, so we would use our calculator, push the y equals button, and then we would type in 4x minus 3. Then we would go to the table, so we would second graph it on the calculator, and then we would look for these values of x in the table. And then we would write down the corresponding values for y. That's probably the easiest way to do it. The other way to do it, if you're doing it by hand, is we take these values of x and we substitute them into this equation one at a time, and then we get an output. So I'm going to do it that way. So 4 times 0, so we're taking this 0 and we're putting it in for x. So 4 times 0 is 0, and then 0 minus 3 is negative 3. So I would write down negative 3 for the y value. So when x is 0, y is negative 3. Then we're going to substitute in 3 for x. So 4 times 3 minus 3. 4 times 3 is 12. 12 minus 3 is 9. So when the value of x is 3, the value of y will be 9. Okay, now we are going to substitute in 6 for the value of x. 4 times 6 minus 3. 4 times 6 is 24. 24 minus 3 is 21. And we will do the last one. We're going to find the value of... I can't erase that. Okay, so we're going to find the value of y when the x is 9. So 4 times 9 minus 3. 4 times 9 is 36. 36 minus 3 is 33. So that's how you would solve that by hand. Of course, it's a little bit quicker if you just type this into your calculator into y equals, and then look for the values in the table. And number 8, for the linear function f of x equals negative 4x minus 8, what will be the effect of adding 4 to the y-intercept? Okay, when we're looking at an equation, this is just like y equals again. So it's y equals negative 4x minus 8. And when we're looking at it in slope-intercept form, right, the m represents the slope, so the number in front of the x that's being multiplied by x represents the slope, and the number at the end is representing our y-intercept. Now, what they're saying in this problem is, what will be the effect of adding 4 to the y-intercept? So I need to add 4 to the value of our y-intercept. I'm just going to add 4, so plus 4. And we get y equals negative 4x minus 4. Now, if I was just to look here and kind of roughly graph this first one, we're showing that the y-intercept is around negative 8. So if I put a point here down at negative 8, and I just drew a rough sketch of what the line would look like, so as a negative 4x slope, and then we look at the second line, its y-intercept is negative 4, so that's going to be around here somewhere, and I would sketch that. Okay, what's the effect of adding 4 to the y-intercept? Well, we're taking this first line and we're just sliding it up here to that second line. The y-intercept increased. It went from negative 8 to a negative 4, so there's an increase here. So we're shifting the line up 4 units, or it's being translated up 4 units. Okay. Nothing happened to the slope. It stayed the same in this problem. And number 9, graph the equation 2x minus 3y equals 6. In order to graph it, we could do one of two things. We could find the x and y intercepts and then graph it. Or we can change this to y equals mx plus b in that format, in the slope-intercept form. I will go ahead and move it into slope-intercept form. So we're going to split our sides. And to be in slope-intercept form, it has to be y equals mx plus b. So we need to move these x's to the other side. So they were here, we want to move them here. Okay, and then we want to get rid of that number, that negative 3 in front of the y. We want it to be 1y, not negative 3. Okay, so in order to move things to the opposite side, we need to do the opposite operations. So if I'm adding 2x here to this negative, to the y, I need to add a negative 2x to the other side. Okay, so they cancel here. I'm left with negative 3y equals, and we cannot combine this 6 and that 2x, negative 2x. They're not the same terms. This one has an x and this one does not. Okay, so we need to keep them separate, and when I write it, it needs to be an mx plus b, so we want the term that has the x in it first. So negative 2x and then plus 6. Since that's a positive 6, it's a plus 6. Okay. Alright, so now we have the y on one side, but it has a coefficient. It has that negative 3 in front. It's being multiplied by negative 3. So in order to get rid of a multiplication of negative 3, we do the opposite, which is dividing by a negative 3. So we divide all of the terms by negative 3. And we're left with 1y equals negative 2 divided by negative 3 is going to be a positive 2/3. Then we bring down the x. And then positive 6 divided by negative 3 is minus 2. So now we have it in slope-intercept form. The m is 2/3. And the b is negative 2. The b tells us where to start on the graph. So we're going to start on the y-axis at the value negative 2. So right here. The m tells us how we move. Okay, it's always the change in y on top. So the y value is going to go up 2. That means from this point I need to go up 2 and then over 3 on the x. So there would be our next point. And then we would do that again. And that's going to go off the screen if I keep going to up and over. So up 2 and over 3. So we will go down and backwards. So we're going to do the opposite. So I went down 2, backwards 3. Down 2 more, backwards 3. So we'll put a dot here. And if I do it one more time, I run out of space. So that basically looks like what our line is going to be. So I'm going to draw a line through that. So that would be the graph that represents this. Number 10, using the following equation, find the x and y intercepts. So this is kind of what I was talking about on the graph on the problem above. You could have found the x and y intercepts and put those on the graph, and then you could have drawn your line from those 2 points, and that would have been okay. So in this problem, it says find the x and y intercepts. That's all they want us to do. So the x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. So to find the value where it crosses the x-axis, I'm just going to treat this as I don't even see this negative 2y here. I'm going to act like it's not there, and I'm going to rewrite the problem as 4x equals negative 12. Okay. So now the only variable that I have in this problem is the x variable, so I need to find the value of x when that y was nothing or it was 0. So I would divide by 4, and we get x equals negative 3. If I wrote that, so if this was on a graph, and x is negative 3, that's about right here, right? Where would that point be located at? It would be located at negative 3, comma 0. So our x-intercept is negative 3, 0. Now for the y-intercept, I'm going to act like this 4x isn't here at all. And I'm going to write the problem as negative 2y, let's make that red, negative 2y equals negative 12. Now I just need to divide by negative 2 to find the value of y. So we divided by negative 2. It gives us 1y equals negative 12 divided by negative 2 is positive 6. So if I graph this point on the graph on the y-axis, y is 6. So that's, say about there, and that's located at 0, comma 6. Okay, so that would be our y-intercept, 0, comma 6. So that's how you find an x and y-intercept. Number 11, find the domain and range of the following function. Okay, first thing I want to do is label domain as x, range values of y. I can see that it's a function. If I do a vertical line test through this, I can see that my pointer is not going through this line more than one time each time I go down. So when I pull this down, it only goes through one time here. Each place, it only goes through once. That's what makes this a function. So is it a function? Yes. If it said, is it a linear function, the answer would be no, because it does not make a straight line. So there is a difference between a linear function and just a function. A linear function will pass the vertical line test, so it is a type of function. That's why it has the name linear function. But if it just says, is it a function, we just want to see, does it pass that vertical line test? Okay. Now for the domain, we want to find the values of x. So if I'm making a box around this picture, I want to know how far does the picture stretch to the left, how far does it stretch to the right? What are the boundaries here? So I'm going to draw my box around this picture. Okay. So now I have the boundaries. So when I look at the boundaries for the domain or the x values, I can see that the lowest value moving to the left here is negative 3. The boundary to the right, so it goes from negative 3, negative 2, all the numbers in between, negative 1, 0, 1, 2, 3, 4. The furthest it moves to the right is 5. So that means any number I pick on this line has to be between -3 and 5. And you can see that in the picture. It doesn't go any further than that. So when I write that, we write them in order from least to greatest. So -3, and our greatest number is going to be 5. And we use the less than or equal to symbols here, and we use x as our variable. So if I took that variable out and acted like it wasn't here, and that and one of the inequality symbols, we would see that -3 is less than 5, and that's true. And if I took this one out, we would still see -3 is less than 5. So that's why we use these two symbols every time from least to greatest. Now what this is telling me is that x, the value of x, is all the numbers you can think of that are between -3 and 5. So it's more than this, but less than this. In the range, we're going to do the exact same way. How low does it go? How high does the whole picture go? So our very bottom number, the furthest that it goes down is -3, and the most that it goes up is to 4. Once again, we write them in order from least to greatest. -3 less than or equal to y less than or equal to 4. Okay, one of the questions that we normally get is, when do I use that equal sign? You always use the equal sign unless you see an open circle. So an open circle, no equal sign. That's the only time. So if you see closed circles or no circles at all, we always use the equal sign. The only time you won't is if you see an open circle. Okay, 12, draw 3 different types of scatter plots on the graphs below. First one says a positive correlation. So we're just looking at, let me change colors here, we're just looking at points on a graph that look like they're moving in a positive or upwards direction. Okay? They're not always going to be perfect, you know, but we can see that the general direction of this is going up. So that's going to be a positive correlation. For a negative correlation, we're going to see a trend of dots that are moving in a downward overall direction. This would be a negative correlation. No correlation, we're just going to see dots randomly on the board that have no general direction to them. They're not going in a positive direction, they're not going in a negative direction. They're just kind of all over the place. We call that no correlation. Number 13, evaluate for k equals -5 into the expression k squared minus 8k plus 13. So we're going to find the final value for that. So evaluate means find the value. So we're going to take that -5 and we want to substitute it in everywhere we see a k. And when I substitute especially a negative number, we like to put it in parentheses, especially if we're going to use the calculator to do any of the calculations. So k squared, so we're going to take the value of k, which is -5, and we're going to square it, minus 8 times -5 plus 13. Okay, so -5 squared, we're going to follow order of operations. We would do our exponents first. There's no work inside of the parentheses, so we go straight to the exponent. So -5 squared is 25, and -8 times -5 is positive 40 plus 13. 25 plus 40 is 65. 65 plus 13 is 78. So our answer is 78. Number 14, what is the equation of the linear parent function? Just something you have to memorize. It's y equals x. If I was looking at ordered pairs, it would look something similar to this. Okay, or -1, -1. All of the values of y equal the value of x. So when x is 0, y is 0. When x is 1, y is 1. They're equal. That's the linear parent function. Number 15, write the equation for the following graph. Okay, for all things we need an m and a b. to write an equation for a line. B is where it crosses the y-axis, so it crosses at 1. And the slope is the change in y over the change in x. I can see that this is a negative sloped line, so my m is going to be negative. And if it's negative, that means I'm going down, so I'm going to go down first. And I could use the 2 points that they gave me, but I also have a point here. Okay, so I'm going to go down 4 and over 4. Okay, so negative 4 over 4 equals negative 1. So when I write my equation, it's going to be y equals negative 1x plus 1. And we don't really need that 1 in front of the x, so we're going to write y equals negative x plus 1. Write the equation of a line that has a slope of 1/2 and a y-intercept of negative 4. In order to write an equation for a line, we need m and b. So when I read this problem, I look for any information that they give me. So slope is m, and y-intercept is your b. So we're going to go ahead and write that down. M is 1/2, b is negative 4. And we'll write our equation now. So y equals 1/2 x minus 4. (17) and 18 says graph the following equations. And this one, y equals 4. I could type this into my calculator into y equals and graph it, and we could see that the line goes across the y-axis. It's horizontal, and it would cross at 4. So right here. Okay, it also says y equals 4, so it will always be the value of 4. And then we draw our line across. Okay. One variable crosses one axis. Over here in this one, we have one variable as well. It happens to be x. We cannot type this in the calculator to look at it. It's the one thing that we cannot do. But we do know that since there's one variable, it's only going to cross one axis, and it's only going to cross the x-axis. And the place where it crosses the x-axis is at negative 2. So we will go back to, and then we will draw our vertical line that goes through negative 2, and that has an undefined slope. Number 19. The equation C equals 0.05 m plus 10 gives the equation for the cost C of a cell phone plan if you talk for m minutes. What is the rate of change in this situation? What does it mean? Okay, rate of change is just another way to say slope. Okay. And if we use y equals mx plus b as our guide, we know that slope is the coefficient of x, or the number that is being multiplied by x. So when I look up here, I see that we have 5 cents times m, so that's going to be my slope, or my rate of change. So we'll write that down, 0.05. And what does that mean? Well, in this situation, since we're talking about cell phone plans, it means that it's going up 5 cents every minute, so 5 cents per minute. So 5 cents per minute. Okay, and what is the y-intercept? Well, that's where the b would be located at in the equation, so that's 10. And what does that mean? Well, in this equation, or in this situation, we're talking about a cell phone plan, so it's 5 cents per minute plus $10 just to have the plan. So it's the cost, or the starting cost each month, or the base cost for each month. Which equation might represent a line of best fit for this scatter plot? we're going to need to draw a line in here that we can write an equation from. We could do a couple things. We could take each of these 4 equations and actually draw them in here and see which one fits best, right? Or we can make our own equation and then compare our equation to the ones that they gave us as an answer. You could do it you could do it a couple different ways. What I'm going to do is I'm going to draw a line of best fit, and I'm going to write an equation from what I draw, and then we'll compare it to the 4 answer choices. So it looks like right here that point that's on the y-axis, I could use that as my y-intercept and draw the line from there, because it looks like that line might represent all of these points. So that might be a good starting point. So I'm going to go ahead and do that. And I'm going to try to draw it through maybe this point here, and then kind of go up through there. Okay. So all of our lines will look a little bit different, but that's kind of close, right? So when I write this equation, I need 2 things. I need m and b. B looks like it's going to cross this y-axis right here at 2. Okay. Okay. And then my slope is positive, so I'm going to go up 1 and over 2 to get to this point here. So up 1 over 2, up 1 over 2 more, up 1 over 2 more. And so that's going to be my slope here, so 1/2. So y equals 1/2 x plus 2. And then we just compare. A is missing the y-intercept that I came up with. So here and here doesn't match. Then b, 1/2 x, good, plus 2, good. So b is still in it. C is a negative 1/2. Oh, obviously I can see that this is a positive correlation, so C would be no good. And D is 2x plus 2, so it has a slope that's too large, so we're going to take that out. So there's B. B is our answer. 21, solve for m. So they want us to find the value of m. What is m worth in this problem? It is an equation, so we will split the sides here. 2 sides of the equation. So I'm going to look at the left side of my equation and see if I can simplify it any, and I can. So we're going to distribute. So I get 3m minus 12. Right, I'm multiplying 3 times each of the terms. And then we're going to distribute on the right side, so 5m plus 60. There's nothing I'm going to combine on each side, so now I need to move things back and forth on the equal sign. I need the letters on one side and the numbers on the other. So I start with the letters. I'm going to move the 5m to the other side. So I'm going to move it from here to here. To move it to the opposite side, I have to do the opposite operation. So instead of adding 5m or having a positive 5m, I'm going to add a negative 5m or subtract 5m. So minus 5m. So negative 3 plus a negative 5 is negative 2m minus 12 equals 60. Then I'm going to take this 12, move it to the other side. And I'm just going to write this over here now. So we're left with negative 2m equals 72. Now it's negative 2 times m, so negative 2 times what number is positive 72? So we will do the opposite of multiplying by negative 2. We divide by negative 2. So we get the value of 1m equals negative 36. $22. Phone company charges $8.75 a month plus 35 cents per minute. Which equation represents the total cost in terms of number of minutes m? Okay, so we're trying to find the cost in terms of the number of minutes m. So our cost equals 35 cents per minute plus the $8.75 charge to have the phone. Okay, so now we just compare it. We need 0.35 m. So A is out of the we're taking that out of our choices because it's not 35 or 0.35 m. So that's out. And B is out because it's multiplying the 875 times the minutes. C is still in, and D is out. So C is our answer choice. So it's 0.35 m plus 875. Okay, 23, sketch a graph of a line that has a slope of -3 and y-intercept is 2. The graph kind of turned out kind of weird when it converted over to a PDF. We'll go with it. So we have m and b. M is -3 and the y-intercept is 2, so the b is 2. So we're starting at 2. And it says we have a slope of -3, so that means I need to go down 3 and over 1. And I'm going to do that again. And then I would go, just continue the pattern, but just do it backwards. So right, down 3 over 1, down 3 over 1, or backwards, up 3, backwards 1, so we get to all the points. And I would just connect the dots, and there's my line. It has a negative slope, so it needs to have a negative sloped line. 24, name 2 lines that are parallel to each other and 2 lines that are perpendicular. For the parallel lines, that means they never touch, so we're looking for 2 lines that have the same slope and would never touch. That would be here. So it's line N and line O. I'm just going to write N and O. And then perpendicular lines, those are 2 lines that cross and make a 90-degree angle. If I know that these lines are parallel, and this is cutting through it, that this is going to make a 90-degree angle, and so is this. So I could write that line M and line N make perpendicular lines, or line M and line O make perpendicular lines. So M and N, or M and O. Okay, given the equation y equals -5/2 x plus 4, if the slope is changed to 2/5 and the y-intercept stays the same, what will be the effect on the graph? Okay, I can go ahead and write an equation for the second line. So it's saying the slope is changed to 2/5. Okay, so when I write this equation, we're saying the slope of the new line is going to be 2/5. And the y-intercept didn't change, so it's going to be plus 4. So if I graph these lines, well, y equals 2/5 x plus 4. Okay, I could graph these lines. So the first one starts at 4 for the y-intercept, and then it goes down 5 over 2, and then the pattern continues. And then we could draw a line. And the second one we came up with was y equals 2/5 x plus 4. So it has the same starting point of 4. And it's going to go up 2 over 5. Okay, and then same thing, down 2, backwards 5, follow the pattern. And we could draw our line. And then we're going to look at our answer choices. Our answer choices say the second line is parallel to the original. Well, those aren't parallel lines, so that one's out. That's false. Perpendicular to the original looks perpendicular. The way that I know for sure is that the slopes are opposite reciprocals. So this slope here was flipped over, so the 5 went to the bottom, the 2 went to the top. So the numerator here is 2 and 5, so it was flipped, and it went from a negative to a positive, so it's opposite and the fractions are reciprocal. So yes, it is perpendicular. They intersect the x-axis at 0. That is not true. That would be here, and they are not crossing at that point. They actually cross on the y-axis at 4. And answer choice D, they intersect the original at the x-axis. No, they don't cross on the x-axis. They cross on the y-axis, so that is also false. So B is our answer. Okay, number 26. Which function best represents the data? There's a couple ways that we could do this. We could write our own equation given the points from the table, or we can substitute the values for x in here and see if we get this as an output for y, or f of x, and we can eliminate that way. Just a real quick, if I substitute in this -2 in for x, 2 times -2 would be -4, and that does not give me that. That gives me a 1, so A would not be a good answer choice here. For B, if we take -2 and substitute it in here, -2 plus 3 is 1. That is an output, so that works. I could do the same here for C. So -2 plus 2 gives me 0, not 1. So this would be out. For letter D, if we take -2 times 1/2, that gives me -1. -1 plus 2 is 1. So that works. So for B and D, that first point works. So now we're just going to take another point and see if it works. So let's just take 6, 5. So I'm going to take the 6 and plug it in here. 6 plus 3 is 9, not 5. So B does not work. Then we'll take that same point. We're going to plug it in here. So the 6 for x. 1/2 of 6 is 3. 3 plus 2 is 5. So our output is 5. That works there. And you should check all of the points to make sure that that's true. Another way to do it would be to type this into y equals and then go to the table, so second graph it, and then you would look for these points in the table. If they don't match, then it doesn't work. Then you would mark it out and you would type in the next one into y equals. So y equals x plus 3. Look at the table, see if the table matches all of the points. If it does, great, that's your answer. If not, mark it out. C, same thing, y equals x plus 2. Go to the table, see if these points match, and then same thing on the last one. At 27, Alex's office has a water cooler. The table shows how many liters Y of water is left in the cooler X days after it is filled. Which statement describes the x-intercept of this function? Okay, the x-intercept means when x has a value when y is 0. So when I look at this table, x is on the top, and I'm looking for when y is 0. Here it is right here. So here are my two intercepts. This is my y-intercept. This is my x-intercept. They wanted to know specifically about the x-intercept. So when I read this, okay, we're going to see that the x represents days. So we have 3 days, 0 liters of water. There was water to begin with, and it went down to 0. So it took 3 days for all of the water to be taken out of the office water cooler. So let's look at our answer choices. A, the cooler holds 36 liters of water. Well, that's how much water was in it when it started, but they're not asking about that. They're asking about what does the x-intercept mean. So A is out. Even though it looks like it is a true statement that it holds that 36 liters of water, it doesn't answer the specific question of what is the x-intercept. Okay. B, the cooler is empty after 3 days. That is true. That is what that x-intercept means. People drink 9 liters per day. Well, if I look at the difference between 36 and 24, that's 12. So that's not even the right number. And D, people drink 12 liters per day. Well, that is true. But that's not the question they're asking. They're asking, once again, what is the meaning of that x-intercept? They don't want to know what the rate of change is. This gives me the rate of change. They only want to know, what does this point specifically mean? So B is our answer choice. 28. For a baby girl less than 1 year old, the function f of m equals 17 plus 5/6 m represents the baby's length, f of m, in terms of the baby's age in months m. What is the dependent quantity in the problem? Okay, so dependent quantity, we are looking for the y value in this problem, because y depends on x. So y depends on x. Okay, and in this problem, f of m is taking the place of y equals, or of y. So y equals, so f of m represents the dependent quantity. So what we're saying is f of m, or the baby's length, depends on how many months that it's been alive. So when I come down here to my answer choices, the rate of growth, no. It tells us that it's the baby's length. Baby's age in months, no. Baby's length, yes. So the answer in this would be C. Okay, 29. Based on the graph, which statement is true? So we're going to look at the graph. We see that we have gallons in the tank for the y-axis, miles driven for the x-axis. We see that the amount of gas in the vehicle, the gallons in the tank, is going down as they drive further. Okay, so the gas is decreasing. We can figure out how much gas they're using or how many miles they can drive per gallon. So we're going to take 2 points. So we're starting with 15 gallons, and here's another good point on the graph. So the change in y is going down 1 gallon, and then our change in x going from 0 to 25 here. All right, so down 1 over 25. So we're using 1 gallon of gas for every 25 miles that we drive. So it says, A, the car drove 25 miles using 5 gallons of gas. No, we just figured out that it took 1 gallon of gas to drive 25 miles. So A is not a good answer choice, so we're going to put false. B, the car had 200 gallons to start with. Well, we can see here that this is our starting point, the y-axis. We're starting at 15 gallons. So B is false. C, the car uses 25 gallons every mile. Okay, so we have labels here, right? It took 1 gallon to go 25 miles, not 25 gallons. So not 25 gallons to go 1 mile. They're backwards here. So C is false. And D, the car uses 2 gallons of gas every 50 miles. Well, we're just going to multiply this by 2, so we get 2 gallons. So minus 2 gallons, and then multiply the miles every 50 miles. So that is a true statement. Okay. All right, number 30. What is the domain and range of the given function? Okay, we are going to draw a box around our image. And then we're going to look for the domain, the x values. So the image stretches from -2 to +3. So on the x-axis, we go from -2 to +3. So -2 is the least amount, and that's less than all of the values of x. And then we get all the way to the number 3. And there's an open circle here, so that means we do not include the value of 3. So we will have just the less than sign with the number 3. because it cannot be equal to 3, because that's what that open circle tells us, so we do not put the equal sign here. Okay, for the range, we're looking for the values of y. So we're going to see, once again, what the lowest and the highest values are for the range. It comes all the way down to -5, and it goes all the way up to +2. Okay, we see that down here at the -5, that we have an open circle that traces back to the -5, so the value of y cannot equal -5, so we write that as -5 is less than y, which is less than or equal to 2. So up here it is equal to 2 because we have the closed circle. Down here it is not equal to the 5 because we have the open circle. (31) Write the domain and range in the mapping and tell whether it is a function or not. Okay, domain is the list of the x values. In a mapping, it's just like a table. It's x on the left here and then the y on the right. So the value of the domain, we are going to list the x values in order from least to greatest. So we have -1, 0, 3, and 5, and we do our little squiggly brackets around that. And our range is going to be the list of y values. So we have 0, 2, and 3. We write those in least to greatest as well with our little squiggly bracket. And is it a function? Well, to determine if a mapping is a function, we look at the x values and we see how many arrows are coming out of it, or how many outputs are there. So if 5 is an input, it has 1 arrow coming out of it as an output. -1 has 1 arrow coming out of it, so it has 1 output. 0 has 1 output, 3 has 1 output. So this would be a function because each of the inputs have only 1 output coming out of it. So we look at the x values, and if it only has 1 output, then we say that it is a function. If there were 2 arrows coming out of this, then we would say it is not a function. So is it a function? Yes. Why or why not? Yes, because each input has 1 output. Okay. Number 32. If f of x equals -3x plus 5, then f of -6 equals what? So if we take f of x, I'm going to write that down over here on the side, and I put f of -6 under it. We can see that the -6 is taking the place of x in this function notation. Remember, this whole piece means y equals. So we're wanting to know, what does y equal when x is -6? Okay, so we're going to take this -6 and we are going to substitute it in for x here, and then we're going to find out what the value of this whole thing is, which we call the same thing as y. Okay, so we will substitute that -6 in, so we have -3 times -6 plus 5. Okay, -3 times -6 is 18. 18 plus 5 is 33. Okay, the other way that we could have done this is we would have taken our calculator, pushed y equals for this, typed this expression into the calculator, went to the table, so we would have went to second graph, and we would have gone down where the x value was -6, and then we would have looked in the y values, and we would have found that 33 would have been in the table next to the -6. Okay, 33. 284 ducks went on an adventure. 24 ducks left the group and went on a walk. The remainder of the ducks filled 2 ponds equally. How many ducks were in each pond? Write an equation to represent this scenario. Okay, so they want us to write an equation, so we are going to have an equal sign. So whenever we see the word equation, we're looking for an equal sign. So we have 284 ducks went on an adventure, so that's all of the ducks. It says 24 ducks left the group and went on a walk. The remainder of the ducks filled 2 ponds equally. Okay. So what we're going to do is we're going to write the equation saying that we had a total of 284 ducks, and now we need to find the pieces. So we had 2 ducks, or we had 2 ponds filled equally with ducks. So it's 2 ponds with an equal number of ducks plus 24 ducks that went on a walk. So all of the ducks combined, so the ones that were left in the pond plus the ones that went on the walk by themselves, together, these 2 pieces, they equal 284. So this is the equation that would represent this situation. Okay, 34. Label whether the following graph has a positive, negative, 0, or undefined slope. When we're deciding if something has a positive or negative slope, we read it just like a book. We read the graph like a book. We move from left to right. And as I move from left to right and I trace my line, it is going down as I move left to right. So we say that this has a negative slope. Okay. This one here, it is going over continuously. It does not go up or down at all. So we have to decide if it's a 0 slope or undefined. We could pick 2 points on a graph and find out that the upward movement would be 0 over 1, and then 0 would be the up or down movement, and then 1 would be the movement to the right. And if we type that in our calculator, we would find out that that has a 0 slope. So we will write 0 slope here. And that's just something you can memorize. If you see a horizontal line, we know that that's going to be a 0 slope. Okay. This next one goes up and down only. There is no slope to it. We could pick 2 points on the graph, anywhere on here, and we would see that it goes up 1 unit and over none. If we type that fraction into our calculator, 1 divided by 0, we find that it comes back as an error, and that would mean that it has an undefined slope. Okay. And in the last one, we move left to right. So when I get to the line itself and move to the right, I see that I'm moving in an upward direction. So we say that this has a positive slope. And number 35, if f of x equals 5x minus 4 and f of x equals negative 24, then x equals what? Okay, sometimes there's some confusion on what to do with the numbers when it's inside the parentheses or if it's outside. But remember that f of x is just another way to say y. So if this whole thing is y, we're saying y equals 5x minus 4 and y equals negative 24. Then x is what? So if I know that y equals 24, I need to find the value of x. Usually in these types of problems, it'll say, then x equals what? Or find the value of x, or find x. So that's saying if we need to find x, then that means that this number is the value of y, and we have to substitute that in so that we can find the value of x. So I'm going to take this negative 24, and I'm going to put it in right here where that y is. Negative 24 equals 5x minus 4. We will separate our sides. I will add a positive 4 to both sides to eliminate it from over here. And we're left with negative 20 equals 5x. Divide by 5. And we get x equals negative 4. Okay. We could have also typed this part of the equation in. So y equals into the calculator. We push the y equals button, type this in, go to the table, and then we could have went down or went up to where it says that y is negative 24, and then we would have found the corresponding value of x, which is negative 4. Okay, 36. Draw a line of best fit on the graph below and write an equation to represent the points. Okay, I will draw my line of best fit. I like this point right here in the middle on the y-axis, so I'm going to try to go through that point there. That's a nice point for our B. So I'm going to sketch the line here. I'm going to use this point right here as well, and then just kind of draw it that way. Okay. So we have to find M and B. We made the B easy for ourselves. We found that crossed the y-axis at 4. So right here is our B. And for our slope, we're just going to use 2 good points. I'm going to use this one here and this one here. We do have a positive slope, so as I move from left to right, we see that's positive, so my fraction for my slope will be positive. So from this point to this point, if it's positive, that means I go up, so I went up 1, 2, 3 units, so up 3, and over 1, 2, 3. The fraction 3 over 3 can be simplified to 1 whole. And then when I write my equation, instead of writing y equals 1x plus 4, right, I can get rid of that 1, right, and I can write it as y equals x plus 4. 37, what is the domain of the given relation? Okay, the domain is just asking for the values of x. So we will trace them back, these points back to the x-axis and see where they touch. So this would be at 1, 2, 3, 4, 5, 6, 7, 8, 9. So the domain, we would need to list each of those values. So we'll do our little squiggly line, or squiggly bracket, and we're going to list them 1, 2, 3, 4, 5, 6, 7, 8, 9. And it is important that we list them individually because there is no numbers between 1 and 2. There's no line connecting these, so this is not a continuous relation here. So we have to only list the individual values. So that's why we list them out. Okay, 38. What is the independent variable of the table below? Okay, independent variable, that is a label, right? We're talking about what represents our independent variable in here. So our independent variable is going to be x, right? Because y depends on x. So that means that y is the dependent variable, and that makes x our independent variable. So it's not asking for the values here. So we're not giving them 1, 2, 4, 5, and 6. Right? They're asking what is the variable. So the variable itself is batches of cookies. So D would be our answer choice here.